By the end of this lesson, you should be able to describe the effects of balanced forces acting on an object. Describe the effects of unbalanced forces acting on an object. The car shown in the picture is at rest. Why doesn't it move backwards? Note that a bus is moving fast past the car. What makes the bus accelerate? A brick is pushed at both ends. The brick is still in its place. Why? What happens if both ends are pushed harder? What if only the right side is pushed harder? Click on the Numbers button to determine the strength for each group. What happens if both groups have the same strength? Neither group shifts. What happens if Group A exerts more strength? Both groups shift to the left. What happens if Group B exerts more strength? Both groups shift to the right. From the previous simulation, you saw that when both groups exerted the same strength, they did not shift. Why? They did not shift because the force exerted was equal, but in opposite directions. When you added more strength to Group A, they shifted to the left. Why? They shifted to the left because there was a net force to the left. When you added more strength to Group B, they shifted to the right. Why? They shifted to the right because there was a net force to the right. Let us explore what actually happened. What are the forces acting on the mug resting on a table? When the mug is on the table, its weight acting downwards is balanced by the normal force from the table acting upwards. A brick is pushed at both ends. It remains motionless. Why? In this case, normal force R is balanced by the weight W, while the horizontal component is also zero as F1 equals F2, but act in an opposite direction. The toy car is moving with a constant velocity. What are the forces acting on it? We can draw a free body diagram to show all the forces acting on the toy car. When the toy car moves at constant velocity, the net force acting on it is zero. The applied force is balanced by friction, while the weight is balanced by the normal force. What if the applied force is greater than the friction? When the applied force is greater than the friction, the toy car will move with an increasing velocity in the direction of the net force. A motorcycle is accelerating. What are the forces acting horizontally? Are these forces balanced? The diagram above shows the horizontal forces acting on the motorcycle. Are these forces balanced? These forces are unbalanced, which results in a net force. The net force is also known as the resultant force. Resultant force equals net force equals forward thrust minus resistant forces. A resultant force causes an object to accelerate. Three boys, Awi, Bala and Chong, are playing with the ball. Awi kicks the ball to Bala. Bala stops the ball before kicking it to Chong. Chong kicks the ball to Bala but misses. The ball rolls onto the road where it is flattened by a lorry. What can force do to the motion of the ball? Explain what happens at A, B, C and D. A force causes the stationary ball to move. The speed of the ball increases. It accelerates. A force stops the moving ball. Another force then causes the stopped ball to move. The speed of the ball increases. It accelerates. A force causes the direction of motion of the ball to change. A force causes the shape of the ball to change. A force can cause a stationary object to move, a moving object to stop, a moving object to change direction, or the shape of an object to change.
The plane flies with uniform velocity. Move the knob on a slider below the picture to change the magnitude of the lift force and observe what happens to the plane as the magnitude changes. A plane flies at constant speed horizontally. The forces acting on it are balanced, namely, the forward thrust equals air drag and the lift force equals its weight. If the lift force is greater than weight, the plane gains altitude. If the weight is greater than the lift force, the plane loses altitude.